Welcome to the game programming workshop, aka Game Creator. I'm Ævar and he is Egill, Gogogic. Why don't you just start?
Yes, I'll just introduce myself and then Ævar will take over and fill your brains with lots of ideas. My name is Egill, I am 29 years old. I've been working at Gogogic since 2008. I've been a Flash programmer and I am a Flash programmer there. And I'm the game audio dude, which means that I'm creating all the audio for the games, basically, and also programming them into the games. And since last Monday, I've been checking on iOS programming. That has to do with audio as well as we speak, but that would be really nice. And I'm nicknamed Wonder to avoid confusion because we have another Egill Arnarsson, which is like one character away from me or something like that. And I like that. I love Steve Wonder and it fits for me. And yes.
Okay. I have been working at Gogogic since 2009. I born 1983, had computer interest from very early age and played a lot of games and made my first program on BBC Basic. In BBC Basic, on BBC Master something, Acorn, yes. And I played a lot of games, and this was one of the first consoles I owned, where you just connected it directly to the PC, or television. And I was always since I saw these games, I was always interested in creating them myself. And now I'm doing that and getting paid for it, which is kind of awesome. These are just to give you an overview of my background, what I have used to create games. I guess I started creating just very simple games in Pascal and Bat scripts. Just press 1 to go to the dungeon, press 2, and it was basically some text with go to. Went to Reykjavík University and did 3 projects. One was top-down shooter that you controlled with your mouse and use your keyboard to move the character around. And you were shooting 2D spiders that jumped on you. Then we ported that kinda into 3D, which had the same mechanics but 3D presence and everything used models and walls and textures. And then Sound Sucker, which was a game based you had this giant thing and you sucked sound out of things and you shot it on a board and you could pitch it and create new music, which was pretty fun actually in Panda 3D. At Gogogic, the first project I started working on when I went there was Soft3 Fiesta for the iOS, which is mostly programmed in Objective-C but a little bit of C++ as well. Vikings of Thule, Floss, ActionScript, as well as a server. And I have done quite a bit of prototyping, making multiplayer first-person shooter with Unity, and turn-based multiplayer strategy games on a game on iOS that used Python backend. And I tried porting one of our games to Windows Phone just to see how hard it was to XNA. And then I'm now working on an undisclosed iOS project. These are the things I find very interesting about game programming. One of the things, it's simply just very fun. And you usually get instant feedback when you do something, you code a little bit and then you press run and you see something on the screen and maybe you can move it. And that's actually very rewarding. It's also challenging because, like, especially when you're making new games, like you cannot always find a book like how to make this game. You have to invent stuff for yourself and find seek out solutions others have made, and be like, yeah, I find it more challenging at least window programming. It's also very fun, like cooperation part of it. At Gogogic and other places, of course, you work a lot with both game designers and graphics people, and you have to work closely with them often to so everyone understands the technologies and what is possible and find a common solution to problems. And it's constantly changing. There's new hardware, new platforms, everything coming each year. So it's, for those who like change, this is a very good field. And yeah, original research, a lot of it. Game technologies are also influencing a lot of things. Like now almost all operating systems can use the 3D GPU accelerator for their UI and to make all kinds of nice transitions and animations. So if you're familiar with game concepts and it helps, just like the iOS is everything is 3D accelerated, and to understand the concepts helps you program in this as well. And then just if you know the game concepts, this gamification of everything, there is. Like now there are achievements for just reading your mail or whatever. So it's good to be familiar with the concepts. But yeah, when I first was going to talk about game programming, of course, okay, this is very easy to talk about. But then I thought how huge the subject is, and it's huge. Like you can make all kinds of games that require slightly different programming. But there are some few things that they mostly have in common. So I'm going to talk about that, and then later you can ask questions regarding to other things. The amount of controllers is, of course, ever increasing, offering new possibilities. Just like touch is now very, very popular, and new things like Kinect and Wii remotes are always offering new and new possibilities. Yeah, I wanted to abstract games as far as I could. When it's either on the other side real time, it always has this game loop, and that's shooter real-time strategy, and turn-based, you do something and there is a fixed result afterwards, and you don't really. This kind of programming can be closer to more event-based traditional programming if you're not doing any animations or anything. So yeah, almost all games, or a lot of games at least, use some kind of 3D acceleration or even 2D games, because it's just it's a way to do things fastest. There are two core technologies, OpenGL and Direct3D, that abstract communication with the graphics cards, and in 2D games the core element I would say is usually sprites, which is just a picture. You're working with picture, you're rotating them, and usually most of the rotating scaling operations are done on the GPU. And the 3D games has the same texture thing and are built up of triangles, all the 3D stuff. Okay, so I'm going to start to talk about the game loop, which is, for me, this was the most radically different thing about programming games, because this is, even if you're using engines or whatever, this is always going on. You have some, can you see? There is a loop, that runs, maybe if your game runs 60 frames per second, instead of just the program being static, it's always doing this loop, and you often have to control it and write it yourself. And this is a typical user input for some game, like check for user input is a user pressing space or whatever, move his player according to that, run AI that moves enemies, resolve collision, and draw graphics. This has to be done normally for 60 frames per second on like 16 milliseconds per frame. So you cannot be doing a lot of synchronous stuff that takes time in this loop. And you also have to program in such a way that you are you're looking at things sometimes in tiny steps. This decided to show a demo with a game loop with physics. It's very similar, but if you're using a physics engine, you don't move objects yourself normally. You just adjust forces on the world, and then in the end, before drawing, you call the physics engine and say step once, and then the physics engine actually moves everything. Yeah, and this is like a small thing that is common for at least people who are starting in programming. Instead of thinking of all actions in terms of time, they do it in frames. Like the lower example here is the bad one that can end badly if the frame rate changes. If you're moving something and the frame rate drops, then it just slows really down. Or if you have a lot of frames, many of you might have seen this for older games, when you run them on a new computer, everything just chip and game over. So it's very smart to think from the beginning in like everything that moves something, like think of the movement in seconds, and just check how much time passed since I ran it last time, and move according to that. And many games have to use collision detection. This can vary from like a simple proximity test, like is the bullet centimeters from the player? If so, he's dead. Or like complex per pixel detection. If you have to shoot someone's finger off or something, you have to be very precise to detect the collision. Brute force checking of collision detection quickly gets out of hand if you don't use any trees or anything. And by brute force, I'm meaning like checking for, like, say you have a game with bullets and you are shooting some enemy, and if you are checking each frame, like collision per all walls in the level with all the bullets, you can see that doesn't really work. So there are all kinds of ways to optimize this, and if you use physics engines, they usually can take care of this for you. But if you have to think about like how heavy collision detection does my game need. If it's not that complex, it's probably better to do it yourself. If it has to do with interacting objects, and physics actually matters, there's a lot of things going on, it might be better to use a physics engine. And they usually work in a way you define objects and apply forces to them, or like you can, and maybe say apply gravity to everything. So there are some free physics engines out there. I've mostly used it for 2D, but you can ask me later for advice. And then there is multiplayer, which is like, okay, it's often if your game requires some complex interaction between entities, it can be easier than doing a complex AI that takes care of it. And this is, I think, a reason why a lot of mods are multiplayer only. It's both, you don't have to create as much content, and it's just less work to actually have multiplayer than write AI. And it's still, like, if you're doing it from scratch, it's relatively easy to do with turn-based games. Don't have to do complex things. But it can come if your game completely relies on this can complicate the debugging process really fast. Instead of just having to run one client, you suddenly have to run two, and and it can be a lot harder to debug things when you have two clients at once, and you might need a lot of screen space, or if your game requires even more than that, you require a lot of people to test. And physics and networking, especially in real time, is that's a hard subject, because in turn-based, even if you have physics, you can just send each turn what the other player does and run the same simulation on both devices, and you mostly get the same result. You can sometimes you have to do some tricks, because calculations can be different between processors on floating point level that can cause changes. But I can point you to actually a very good article, but it's a bit advanced for real-time physics. But I think the first multiplayer game I saw with physics was Half-Life 2, and then physics had been with advanced physics, like boxes flying around and stuff. So yeah, be careful if you want this, or find an engine that already takes care of it. And even if you have turn-based, you might have to write a server or database depending on your game. It has to be persistent. So adding multiplayer can complicate the development process. Yeah, I wanted to get this in. I think, for me, math, games are the most fun ever to learn math. Okay, some think it's scary, but usually you have a problem, might have kind of idea how to solve it, or you don't, and you go and find what math you how to solve this with math, and after you have really solved something with a real problem with math, it sticks better, for me at least. And with the linear algebra, I got through it first, and then I took computer graphics, and then I really understood it to the core, much better than I ever did, because I had to use it in practice. And yeah, laws of physics, not strictly math, but good to know some of them if you're writing your own physics stuff. And even if you don't, then you have to get familiar with physics concepts when working with physics engines. Yeah, and then I have worked with several engines and frameworks, so I'm just going to go through them quickly. The ones I've worked with, the ones I'm going through aren't really all on the same level. Some are just basic frameworks, others are engines. And yeah, just going to share my experience, I guess. Yeah. Unity 3D is pretty cool. You can start right away, and you can actually mark some objects, sync this object between networks, and it's looks like you can do a lot of things. But when you are actually going to do some radically different things than first-person shooter or something, or a racer or something, you have to get into this like every other stuff. And you can write code in JavaScript-like language and monoscript, which is kind of like C#. One of the bad things I've found with working with this was you kind of always had to edit everything in Unity. I don't know if it has changed with the newest version, but it's like a package with everything. You put assets, you put code, you design levels in the same IDE, which I found slightly uncomfortable. And if you are going to do, like I found out with making this first-person shooter, like advanced, like in multiplayer, you have to do all kinds of things. You have to like predict what the other people are going through because you don't get constant updates. So you have to, if someone player is running, you have to like make him run until you get the next update and correct according to any changes. And you have to program this yourself, really. Even if it's has this simple synchronize flag, it's not that simple. It can show you stuff, you could get basic stuff working, but to have things really smooth, really cool, you have to do the same things as you do with other engines. For simpler projects, say too much. Usually, like if your idea is maybe some 2D game with simple physics or something and simple gameplay, it's maybe an overkill to use a completely fully blown 3D engine. It's pretty cool with art and seeing art real in the game. You can actually use Photoshop documents. You can have them in the project and you update them and they just get it and you can use it as a texture even if it's still in a Photoshop document. And same with 3D, can't remember the exact support, but a lot of 3D packages you can just see it directly in game. So, and it's free like for indie projects at least.
Not Photoshop?
Not Photoshop, no. You can use GIMP or something else. And then Cocos 2D for iPhone, which is like a basic framework that abstracts OpenGL. It's object-oriented, and you manage basically a scene instead of having to create that functionality yourself. You have a scene, and you make objects, and you add to it, like add on a scene with a certain position, and Cocos 2D like that renders everything for you. You don't have to think about it. And of course has texture loading classes and sprite classes. It's small but very useful. And they have cool animation functionality. You can just animate every object like to either scale or rotate or do anything. It's very smooth. You can chain animations together. And it has nice touch management, but it's only on iPhone. There is Cocos 2D for Mac and PC, but Cocos 2D for iPhone is much like that is where the development is going on. So I can't say for the Windows and Mac version. But it's if you want to do most yourself, it's a very good framework. And we are actually using it at least in 2 projects at Gogogic. X and A, which is the Microsoft solution. It's actually quite good. It abstracts all the input management and supports Xbox 360 controllers. It's done in a very cool way actually. How you listen keyboard buttons are pressed and what the mouse is doing. It's still like relatively low level, but has a lot of helper classes. Manages sound and graphic management, and that only uses Direct 3D because it's Microsoft. And it's, to my knowledge, at least the last time I checked, was you can only write in C#, but you can deploy on Xbox, Windows Phone, and Windows. And share actually a lot of the code. So I tried making some 2D project in it, and it's quite cool. And it actually, you can get like whole games with source code as example projects, which can be very helpful, and it's documented. And I would actually recommend it if you like C#. Cons, only Windows compiler IDE, even if you can, it's a con if you are on something else. No built-in physics engine. It's not like really a con because you can connect a lot of physics engine to it easily, and it's well documented as well. Panto 3D is the one I used here in the Reykjavík University, and that's actually quite fun to work with. And I was just looking at it. It's been like 2 years or so, no, 4 years since I last used it, and it has been in massive development since then. And it has built-in physics engine. It has support for Python and C++. Only had Python when I was working with it, but you can do as compared, like when you saw, I had took computer graphics and we made some example projects there by making engine from scratch. But in this, it's very relatively easy to make a lot of stuff cool, and you can still control the programming a bit. But yeah, if you don't like Python, then you might not like this. And then finally, your own. It's the biggest pro, of course, is that you learn a lot by writing your own engine. And it also helps you to appreciate like frameworks and engines more when you get them, because you understand all the problems that have to be solved. And when you when you have written your own engine, it's easier for you to understand other engines, because you know it deeply what has to be done to render graphics and maintain structures. Less code to understand. Well, if you are not copy-pasting all day, it's if your project is like medium complexity, it's less code that you have to write really, or you don't get lost in framework code. It's a smaller project, which is can be handy if the idea is simple enough. And potentially faster than ready-made engines. It's unlikely but possible if you are like some engines are maybe trying to do everything, and if you write something that's just doing one or two things, it can be faster. But of course the con is it takes a lot longer to do less, especially in the beginning, like just rotating box in a nice way, in an object-oriented way. You would have to write a lot of code before you get this capability, but then you can use it, reuse it. And what's the worst thing, I guess, is possibilities of bugs on all levels. This is of course true when you're using frameworks, but unless you really trust your code, when something goes wrong, you can like, oh, is this in a base texture class, is this model class, where is this? And you can't trust any code because you just wrote it.
You can, of course, test the code and get more confidence on your own code if you write tests around it.
Yeah.
Spot the bug.
Recommend that. At least like visual test to test all your functionalities.
Yes.
And then I wanted to talk just a little bit about BugStudy, which is a like physics engine ported to a lot of languages and frameworks. We have used it now in 4 games at Gogogic. It's very lightweight, but gives you quite nice collision detection, and if you want physics to be part of your gameplay, it's also pretty cool. And by the engine being on more platforms than one, there is a possibility of using, if the simulation is close enough, for multiplayer between platforms. But we haven't really tried it yet in practice. What's nice, it takes care of most of your collision detection, which is a handy feature. It's very optimized, it's written, it's very fast, and it's always coming new versions. It's just, I really recommend it if you are going to make a 2D game and want some cool physics features like boxes falling or gravity, or just for collision detection if it's a little bit complex. And then just final advice. Not final advice, just some advice I thought of for you guys. Is like one of the things I found out when I was getting started, like looking at downloading some relatively large open source game project, is like you don't gain much from it if you don't understand like the concepts or know what you're looking for. And sometimes it's just like weird standards or whatever that you see. And it's better to just, instead of like downloading source codes and looking at them right away, just try to do something yourself in small steps so you can understand it like your understanding of the games builds up. And yeah, try to do the simplest solution possible when you can. You don't have to simulate reality, you just have to make sure that the player's perception is what he thinks what he's doing is correct. One example, I noticed like Duke Nukem 3D when you went through an elevator, because the engine didn't really support 2-layer floors, you got teleported somewhere else, and I was like, hey, this is cheating, but normal players just didn't notice. You just went up an elevator and you were on the second floor. So try to use as many tricks as you can like this, because yeah, it doesn't have to be copy of reality. And object-oriented design makes it easier in the medium and long run. First, when we were making, it's, if you know object-oriented design, it's just easier to work with things, add stuff to the scene and not have huge main files somewhere. Find developer blogs for your selected platform. Definitely just someone who is always writing about, like makes games for in the same environment you're doing. And yeah, don't try to go cross-platform, especially with C++, like so it builds on Linux, Mac OS, and Windows unless you really have to, because there is a lot, sometimes a bit of work, some if-defs and different headers between machines, and if you're creating a game, you might not need this slowdown. And yeah, search for solutions when you know your problem to see if someone else has solved it and you can use the solution. And yeah, using ready-made engines can be double-edged, because especially the bigger engines, there's like so many features and possibilities that you can just like don't know where to start. And I definitely recommend doing some just smaller projects to understand what you're dealing with. And this is, I can send this link somewhere. It's actually on network physics and network physics. So yeah, Egill's gonna continue, and then later afterwards we will take questions.
Yes, I will be brief. It's just kind of two things I'll talk about. Just pragmatic development tips. That's not just for games, but probably all development. Then I'm gonna do a brief talk about putting audio into games, because you know, if a game hasn't any audio, he sucks. Let's be real. No, that's just joking. So, pragmatic development tips. Yes, these are what my opinion is about what can be done good. So there's always this time. It flies when you're having fun, and designing a game is a lot of fun. So, and we're competing against it. So use it wisely, like Yoda would say, or Gandalf. It's not like the song "Time is not on your side," which is the Rolling Stones song. So that's wrong. Okay, so a good thing to do is define the requirements for minimum viable product, which is a buzzword probably. I know but it's a good term. It means that start setting those requirements of what that you want to come and produce, and you're satisfied. So it's just a stripped down core functionality of the game. And then you have the nice to have requirements that you can also list down, but you are really focused on what is the minimum viable product and what is nice to have. And this should be iterated like everything else, for my opinion, which is like the Scrum process, and it comes from the ideology that software is always changing and the requirements and the technology are ever changing. So you have to be quick to be prepared to change and make your code and everything in such a way that changes are not really painful and hard. You can divide the requirements into two, and it mainly because I think it's how you test them and get acceptance. Like, this requirement is finished, it's done, I tested it, and it's functional and cross-functional. So functional is just like some function in a game. Cross-functional requirements are more like how many players your game should be able to have, and load balancing and those tests which are kind of different at testing. And keep everything in a version control system except the compiled artifacts, which is the executable file and maybe something else also, probably. Do you know what a version control system is? It's like Subversion or Git are two examples. So that's what I'm talking about. The meta term is version control system, and there are lots of pluses. It's easy to be a group of programmers and develop on the same source, which is probably the obvious benefit, but there are others. And when I say everything, I am meaning the source code, runtime assets, pics, and configure files like XML or something, whatever the format is, audio files, etc. Library source, which is compiled binary source like jars in Java and Swix in Flash and the likes. Build scripts, and even requirement list that I talked about earlier, and game design documents and everything should be in a version control system. It doesn't have to be the same one for the code, but I recommend at least having the versions for the requirement list and just a backup mechanism. For example, if someone has an outdated version of the requirement list, which is likely to happen if you just have a file that someone is copying and pasting and stuff, it can be costly, but it's more likely in a big project that is cross-country and stuff. And yes, the project should not only reside on one computer that goes into the bus and into some house every day. And that has happened in a project in the past for me. And, that just stops everything. And, if he loses the computer, you're screwed.
If I could interject, even if you're the sole person working on something, it's still good to have it in version control. And the time that takes to actually learn it, just in a month, will definitely pay itself back many times over.
Yeah. Yes. Yes, and a little thing about deploying the game for demonstration, or just deploying it in the environment it should run on. It should be a one-click operation, or kind of like that. It should be effortless and unlikely for human errors, because we make mistakes, and that's why we're human. So, and we are programmers, so we should try to automate everything, including the deployment process and just everything that we're doing. It should be really natural for us. So if the deployment is becoming a multiple step sequence done manually, then it's time to at least consider to automate it. It depends on how huge it is or small, the process. And you can automate it with build scripts that should be also kept, like I said, in the VCS. And there are script languages or build languages like Ant in Java, and Maven, and Ruby, and Nant, and probably a lot of more. And you can go one more step in deployment by having an integration server to make it effortless. So integration servers are like Jenkins or TeamCity and more, and they can be configured to be continuous integration servers, which, for my opinion, adds a lot of benefits. And the next slide is about that. So continuous, that means like continuing or repeated task or something like that. That means that every change you push to the VCS, a job on the integration server starts. And the job builds the project build script and gives instant feedback if the build breaks. For example, if a compile error occurred, so it didn't compile, and you get it right away. At least, yes. So that's what you gain. You gain an instant feedback about the health of your project. You know, and the feedback is the red dot on the server side, you know, where Jenkins, you set up Jenkins or whatever integration server, and you can have it email you, SMS you, and have a lava lamp at the office showing the build. I think that's really cool, or something more hardcore. That would be really cool. So it's really visual. You have the team, and the project should not remain broken. It should be a priority to fix it. And also we have a Chuck Norris plugin on our Jenkins, and so it can have fun with it, gamify this like everything else. And CI is it's a thought process also, and it can be done manually without the integration server, and it's just the mentality of you run a build script and you get feedback. Is it broken? And then we fix it. And you can have like a Chuck Norris doll that's here when everything is okay. And if someone breaks it, he takes it, puts it on his table, and fixes it. But the whole team should also be fixing the problem. A good CI setup, yes, tells you immediately that the game works or doesn't. And a good CI system would also run tests. And test is a huge subject, and I'm fascinated by it, and I'm learning more about it. But there could be running unit tests every time, and component test, integration tests, check if all the systems are working, and etc. And with that and manual test, you can sleep well at night. So it will reduce like the stress. And I encourage to deploy the game from the beginning. Always have a working version of it that you could easily just show, this is my game, and just start it. Don't delay it until a few hours before you're supposed to demonstrate it, because then you can have a panic situation.
Maybe we should rest the audio and get to questions.
Yes, this is audio. I'll be brief. So, defining audio for the game, it's typically divided into music and sound effects. And sound can be a part of gameplay. It could be a user input, like the more you scream, the more powerful damage you inflict in the game. Scream in the microphone, it's useless to scream. in the corner, probably. It could output gameplay info to the user. For example, when you hear that the enemy in the next room is to the left of you in the first-person shooter, and you gain a benefit of knowing that, etc. Sound effects, they can complement a user gesture, mouse click, or graphic animation, and the music can intensify the mood of the game. Here's a slide that maybe should have been in the beginning. It's just about who are Gogogic. We're a game studio in Reykjavík, Iceland. Create games on different platforms with the priority of developing cross-platform. And our games are, of course, high quality and high involvement social and casual games. Casual. And back to the sounds. Composing or finding sounds. So you can compose sounds in a sequencer software like GarageBand, Cubase, Logic. GarageBand is, free if you buy the Mac, of course. Kind of free. And to find music online, there are free sounds online. It's sounds with no license, public domain license, Creative Commons license, but they vary, so just read the specific license. And there's a free 8-bit engine on that link, which is cool. You got these retro 8-bit sounds. And then you can buy, of course, and there are licenses there too, but it should be safe. And soundsnap.com is a site that I use a lot. Implementing audio and code. There are several ways to do that. In desktop and web apps, it's most effortless probably to just embed the audio. That means the audio files are compiled into the app executable at compile time. And that means that the audio file size is added to the executable. And that could become a problem, but probably not for, start of a game or in a contest. Just do it at first, probably. Minimizing audio file size is a big part of game audio, especially in web and mobile games, which Gogogic is working on. So minimizing that is cut the file length, make the music into a loop as short as possible, and program it to loop in code. Compress wave format to MP3 or M4A, and that lessens it by 10 times circa. It depends on the compression rate. There might be limitations on the programming platform, what it takes. Flash takes MP3. You can do all things that Flash provides with MP3, and it's limited with Wave. So it can be limitations. Convert stereo to mono halves the size, and delete silence in start or end of audio files. Could minimize the size also. And there's AutoCity, that's open source, that does that fine and well.
Okay.
Play now. Yes.
I guess we just go to questions.
Yes.
Yeah. Any questions? Have you, like those who are creating a game, have you decided on a platform or an engine yet? Can I ask what you picked? Why? Okay. Unity? You too? Unity. Okay, Unity is very popular, I guess. Have you started working with it yet? Yeah. Do you, are you running into problems, or, how do you like it?
There are loads of videos on the internet.
Yeah. It's actually, pretty cool. It's very powerful, especially for being free. It's at least cool to check out, especially with the easy art integration. You don't have to think too much. Are anyone thinking of creating their own engine? No? Okay.
Yeah, I'm trying to.
Okay, you're trying to. Any more questions? basic tips on Unity. I don't know. Like I did some tests. I used Blender with it for the 3D models, which actually worked quite nicely. Well, I would say just it's easy to get lost in it playing with things. Like I would at least recommend like knowing what you are going to do exactly before you start, because otherwise you might get lost in tweaking particle effects on rockets or something that you really don't need. So I guess that's my primary recommendation.
Have you tried processing to pull it up? So
The what?
processing programming language.
Processing programming language? No. WebGL? Not yet. I have kind of stayed like I went straight from school like into application development because I've never been like the web too much, mostly because of all the different browsers. You make it once and it gets ruined on everything else. So no, I haven't. I've seen some very cool demos though in WebGL, and they're not here, but they were in the last IGI. They actually programmed a game in 48 hours in WebGL and JavaScript, and it was multiplayer. They are good programmers, but like they managed still to do this. So it's showing, especially with all the browsers getting up to speed, it's starting to be very cool. And also, like the newest Flash player now has, it's like, okay, WebGL. Games are getting more cool in browser because they now have access to the GPU. So like that's something you can try. There are a lot of demos of WebGL, but you might run into problems between browsers as always.
Do you usually keep the whole game project in one version control server?
The question is, do we usually keep the whole project as on the same server?
Yeah.
So
do you
the
have
question.
all the code, graphics, and everything on one server?
We have kind of been trying to work this out. Usually the graphics people have used Adobe Bridge for the graphics. They used Subversion for some of them for a while, but it's especially with branches and stuff, and like graphics people don't like to, they shouldn't have to know too much about version control system. Now it's basically like the graphics people use this Adobe Bridge. We pull the graphics from there, and the programmers use Git mostly, and Beanstalk for storing it remotely, which is quite nice.
And we are starting to like have the exported graphic file in our Git version. That means like a graphicer is working in Photoshop and he has a Photoshop file in a bridge, and he creates, the artifact file, which is a JPG or something, PIC file, and we're starting to store that in our revision. So everything the game needs is in the repository.
Yeah, we usually put the graphics like after we have got that. Like the graphickers have internal repositories, but we put the graphics in the version control, when it's ready.
Yeah,
Graphics and so
on. Put one repository and you have a fully functional game.
Yeah.
Yes, and if you...
the idea is, ideally, and that's the case most of the time, just you download the source code and you build and it runs. And that's the way it should be, in my opinion.
And you have a automated task, just to take the graphics and put it in the bin folder where the application is also, and you can pick it up and load all the files and stuff. Yep.
Any more questions?
Is there any common pitfalls in Unity that we should be aware of?
One of the things, I guess, like with I mean, you really have to like write your own advanced network code with client-side protection, decide who is going to be ruling like the server or whatever. And it looked like very easy, but like there are now I think 2 first-person shooters real game in Unity, and one of them is getting like they're always adding to it. Yeah, I can't especially like say certain pitfalls. It's just you might not be getting as much free as you thought in the first place. Okay. One more question.
Please.
No, okay. If there are no questions, I guess we'll just wrap it up. And I guess the idea is we can like see your project and give opinions or tips, and yeah, see how it's going. Okay.
Thank you.
Yeah.